Hello everyone. In this lecture, we will learn about iterative statements, commonly known as loops in C++. Loops allows us to execute a block of code repeatedly without writing the same statement multiple times. We will explore the for, while, and do while loops along with nested loops best programming practices in this video. Starting on with what is iteration. So iteration means repeating a set of instructions until a specified condition becomes false. Loops help reduce code duplication, improve readability, and make programs more efficient. There are three types of loops. C++ supports the three types of loops: for, while, and do while loop. The choice depends on whether the number of iterations is known in advance or when the condition should be checked. To start on with the for loop, this is the best, and when the number of iterations is known, it is best to go on with for loop. It combines initialization, condition checking, and updating it in a single state, updating the value of the variable in a single statement, making it compact and easy to read. So to know more about the anatomy of for loop. For loop has actually four parts. Okay, initialization, condition, update, and the body of the loop. Initialization runs once the condition is checked before each iteration. The body executes if the condition is true, and the update prepares for the next iteration. This happens one by one in iteration. And here is the execution flow. Notice how the value of the loop variable changes after every iteration. Once a condition becomes false, the loop terminates automatically. Here is the counting example. The program prints the numbers from 1 to 5. The variable starts at 1, increases by 1 after every iteration, and stops once it exceeds 5. Here is the example of the sum of n numbers. Here the loop calculates the sum of first n natural numbers. The variable called sum accumulates the result during each iteration. Here is counting down in reverse counting example. In this example, the loop starts from 5 and decrements until it reaches 1. Next comes the while loop. While loop is used when the number of iteration is not known beforehand. The condition is checked before every iteration here. In while loop, initialization happens before the loop begins. The condition is tested before every iteration, and the update must be written inside the loop. Forgetting the update can result in infinite loop here. Here is printing numbers example. This example prints a number of numbers from 1 to 5 using while loop. The output is the same as for loop, but initialization and updates are written separately here. In for loop, all the things happens in same statement. Initialization, condition checking, increment, decrement are done in the same line, whereas here it is all done separately. Here is sum of digits example. Since we don't know the number of digits in advance, a while loop is appropriate choice here. Next comes do while loop. So do while loop differs from the while loop because the loop body executes first and then the condition is checked afterward. Therefore, it always executes at least once. Menu example. A common use of the do while loop is displaying menu. The menu appears at least once and the user decides whether to continue or not. While comparison between while and do while. When the condition is false initially, a while loop executes 0 times, whereas a do while still executes once before checking the condition. Next comes the nested loops. The nested loops is simply a loop inside another loop. For every iteration of the outer loop, the inner loop executes completely. Here is the multiplication table example. In this example, nested loops are used to generate multiplication table. The outer loop controls the rows and inner loop control prints the columns. Next comes a pattern printing example. The nested loops are widely used for pattern printing problems. Here the inner loop prints stars while the outer loop controls the number of rows. Next comes the loop control statement. Sometimes we need to alter the normal flow of the loop. C++ provides break to terminate a loop immediately and continue to skip the current iteration. So here comes the break statement. The break statement exits the loop as soon as specified condition is met. Any remaining iterations are skipped here. Next is continue statement. Continue statement skips the remaining statements in the current iteration and moves directly to the next iteration. Next is range based for loops. So modern C++ introduced the range-based for loop, which is useful for traversing arrays and containers without managing an index variable. Here is the example. An element of the array is processed automatically here. The code becomes shorter, cleaner, and less prone to indexing errors. Here is the vector example. Range-based loop also works with vectors. The example is displayed here. The common pitfalls here are one common mistake is forgetting to update the loop variable that results in infinite loop, and this has to be always taken care of. Another mistake is using incorrect loop conditions that prevents the loop from terminating. So conditions and updating the variables are very important here. So best practices: always choose the appropriate loop for the problem. Keep loop bodies very simple, avoid excessive nesting, use range based loops whenever suitable, and ensure every loop has cleaner exit. And the major takeaways from this session are the loops are fundamentals to programming because they automate repetitive tasks. Understanding loop execution and selecting the right loop improves both efficiency and readability. So, in this lecture so far, we have learned about for, while, and do while, nested loops, loop control statements, and best programming practices. So, mastering loops is very much essential because they are used extensively in solving real world problems. Thank you. See you in the next lecture.